Welcome back, physicists. Here we go. This is resolving forces. This is part of lesson 4, and this is for higher tier only. Okay. First of all, have a go at this starter, which is occurred to construct a resultant using the parallelogram forces. Outline the method. Okay. And I'm going to one pause now. So, I didn't talk about the method. How would we do it? We would construct the parallelogram of forces for each one, and then join up to get the resultant. I do apologise, forgot to put that on the starter. If you're unclear about that, go back to the end of last lesson, which was the last thing, which was constructing those diagrams. So what we're going to do today, we're going to draw a force diagram to show how a single force can be resolved into two components. That's the opposite of finding the resultant. We can actually take one force and split it into two parts, and that can be very useful. And we're going to calculate horizontal and vertical components of a single force using a little bit of mathematics, a little bit of trigonometry from your maths lessons. Okay. Now then, just as we can actually add two forces together to get one force, often it's useful to take one force and break it up into two components. Here's a kid throwing a basketball, and there's the force that he's applying to the ball there, and you can see it's going off at some sort of angle. Now, often in physics, it makes sense to do something like this, to take that force and break it down into two components, a horizontal component and a vertical component. If you remember, and this was mentioned in the last video, forces are horizontal do not interfere with forces that are vertical. They are completely independent. Okay, they don't interact with each other because they are at right angles. And so to solve problems in physics where we have a force at any old angle, it makes sense sometimes to break it down into its components, two forces, that when you add them up, add up to the actual force that we're looking at. So that's what we mean by resolving into components. Resolving. How do we do it? We can do it two ways. One way we can do it is graphically. That means by drawing a scale picture and then drawing in the horizontal and the vertical. And so if I was to do that, I would choose a scale, a suitable scale. I would construct the angle with a protractor, and I would complete the triangle and then measure the size of these forces. Now, in the parlance of you young people, that's long, because there's a better way of doing it. If we know the size of that force, that is the hypotenuse, and if we call that x and y, we know from trigonometry that the cosine of that angle, cosine is adjacent over hypotenuse, which gives us x over 6 in this case. And we can also work out the sine of that angle, which is the opposite over the hypotenuse. And so we can directly calculate the answer straight away. Okay. And that's a better way of doing it, because you'll get a more accurate answer because of your scale drawing. There'll always be some sort of uncertainty and some errors in there. Okay. Pause that. Pause that if you need to have a look at it and make a note. Let's move on. So here are two examples where we resolve forces to make the problem easier. Here's an aeroplane. Imagine we're looking at it from above and the wind is blowing at this angle onto the aeroplane. The aeroplane is obviously moving forward, and so we need to know what the force horizontally is trying to slow that aeroplane down. And we could do that. We'll do that now. Do that with trigonometry. This time, look, we break the angle like this. We've got the x component and the y component. Whoops, apologies. And so we could actually solve that now because we've got the size of the force, that's 800 newtons. We have an angle, and so we could use our trigonometry to solve that. Okay. Let's look at the second example. Here's a box on a slope. So there's obviously a force pulling it down the slope, that's gravity. There's a horizontal force which can pull it down the slope. Y in this case, and then there's a force here. And we can then add in our angles. Whoops. We could say we could prove by trigonometry again that this angle here is 30 degrees, and then we can work out the sines and the coses and get our solutions. Okay. Now, the only way to do this is to practice of it. So here's one that you can practice. Here is a force of 8 newtons acting at 40 degrees. Can you work out the horizontal and the vertical component? And I would like you to try that both ways. Okay, so you can pause that. I'm going to unpause now. I'm not sure if I've got my pause button on. Oh, I have, yes, good. But I'm going to unpause now. Okay, and we should get a result like that. Okay, so here are 2 questions for you to have a go at. These are the 2 questions. What we need to know is the components on the aircraft, and we're looking for the components on the block. Now, to this question, I've helpfully added the force diagrams, the component diagrams for you to have a go at. Have a go at those now. And we'll unpause now and let's look at the answers. Okay, so we should get answers like these for these, okay? Now, if you're having trouble with that, and this is higher tier, and this is the highest part of the higher tier, drop me a mail and I'll do a solution. I'll go through the solution. Have a go yourself. Okay. Hopefully, I've introduced you to these 2 areas, and this is high tier only. So enjoy.